Hey everyone, day 4, Advent of Code. Let's get it. What is it? So, I already did the question. I actually live streamed it. If you want to see that, click here and you can see how I solved it, like my thought process and stuff like that. But in this one, I'm just gonna pretty much explain the solution and try to keep it streamlined. So pretty much the first part of the question was that we just needed to find. We pretty much just had to find Xmas, all occurrences of Xmas, specifically this word, in a array like this. Well, we're given an input like this, but we want to parse into 2D array so that we can do traversals on it. But let's see. Yeah, we pretty much wanted to find Xmas in there. So you could see here, let's just copy and paste this into my Excalidraw. So we're pretty much saying we just need to find Xmas, but we're allowed horizontal, vertical, diagonal, written backwards, or even overlapping with other words. It's a little unusual though, as you don't merely need to find one instance of Xmas, you need to find all of them. So pretend this is the input right here. It said we need to find all 18 occurrences. So let's just use this also below. So pretty much, you see here, that counts as 1. We can also look diagonal. That counts as another one. We could also look here. That counts as another one. We could look vertical. That counts as another one. So the answer here is 4, right? But then you can see this one, we have one right here, Xmas. So you're just trying to find all occurrences of Xmas. So here we have 1. We look at this diagonal, we have 1. Let's look for other tricky ones. This one's like Xmas, but going like the other diagonal, like going backwards. That's another one. Then there's one like going backwards, but up and to the right. That's another one. And then this one, same one, going up and to the right, up and to the right. Oh, sorry. So we literally just need to capture all instances of Xmas, regardless of the orientation. So pretty much how I did that is I converted this thing into an array. And then when I found X, all I pretty much did was check if Xmas was here, check vertically, right? Then I'll also check going down, vertically but looking down. Then I'll just look left horizontally, right horizontally. And then I'll also check the diagonals. I'll check, is there any instance of this, right? Is there any instance of this? I literally just, there's pretty much 1, 2, 3, 4, 5, 6, 7, 8 cases. Then I'll check here, right? You pretty much have to just check all options here. So yeah, that's pretty much what I did. So the first step for part 1 was essentially, what I did is I took the output, I split the output into new lines, and I removed the first empty lines. And then pretty much when I had that, I turned it into a grid by looping through each line and extracting the characters out. That gives us something that turns an input from that's AAA, or sorry, something like this, to something like a 2D array that we could actually operate on. And then we get C, S, A, S. We get D, F, D, something like that. That's what this code does. Then what I essentially did is I just did like I looped through my array, and the moment I found the X, I checked the verticals, I checked the horizontals, then I checked the diagonals, right? So checking vertical, all I literally did is like look -1 up, -2 up, and -3 up. And then I have this get car that essentially, like, if you try to get something that's outside of the array, it returns a F. Like, this is, I pretty much just wanted to return like a random character that it should never match on, so I don't have to worry about the bounds checking. So yeah, that's essentially what I did. So to check vertical, I pretty much had something like this. Then I would do like -1 to capture this, then -2 on the row to capture this, then -3 to capture this. And then I tried to make sure this was M, A, S. Then I did like +1 to capture here. And then I tried to see like if that actually exists there, right? So if like joining the -3, -2, and -1 equaled that, I counted up the result, right? I kind of did the same thing for the diagonals, but instead for the diagonals, I used I tried to automate it more because I didn't want to like write out all the cases. So yeah, this was pretty much it. Like I used the different variations, so it's like adding 1 to the rows. Here, I'll copy this over. Shoot. So pretty much adding 1 to the row, and so pretend this is my value. So adding 1 to the row in the column will get us like this diagonal going like this way, right? So you can see I only loop 3 times, and I try to capture all those, and I build like a list of all the characters in this diagonal. And then what's 1, -1? 1 is the row, so that captures like this specific diagonal. It goes down this way, and I try to capture them in the order that I see them, and then I try to join them, and it has to equal MES. And then what's -1, -1? That's like capturing this diagonal, right? And yeah, still like I join them and just try to see if it equals MES. And then yeah, this is like the final diagonal going this way. So if any of those actually equal, I increment the count by 1, because that means I found like an Xmas. We don't have to check for X because we know we only went into this function if we found the X. So then we pretty much just check the verticals and diagonals. So that's the answer for part 1. Where is it? Just writing down timestamps 22. Let's look at how we do part 2. So part 2, actually today part 2 was actually easier than part 1. Pretty much all they mentioned was like looking for instructions. You flip over and you find that this isn't actually Xmas puzzle, it's an Xmas puzzle in which you're supposed to find 2 MESs in the shape of an X. So you basically have to look for 2 MESs like crossing each other, forming a X like that, right? So the key thing to know is that like A is always going to be in the middle for any, like if we have this, right? We pretty much have like different sorry, delete this. We do have different orientations. We have like that. We have like the M's are at the top. We have like the M's are on the side, like that. What else? We have the S's at the top like that. So we have multiple variations. And then we even have like if you flip this, like, I think that's all the four orientations. Yeah, something like that. But essentially, you'll see here that, let's look here. Oops. So it grabs all the different orientations. You could see this one right here, XAMS, is of like type 1. So that's of type 1. What is this? Then you'll see this one. So there's even more, because we even have like the other variations of like, okay, A is always in the middle, right? So M could be like this. But then we could also have like wait, M S. Okay, actually that one's this number 2 right here. That's number 2. What else do we have? This right here is number 4. So it looks like we only have 4 variations. This right here, S, is number 3. So we pretty much have to just check these 4 variations. But the way I did it was pretty much, I just checked the diagonals. So I kept the code for getting the character. I kept the code for converting the grid into, or converting the input into an actual grid that we can traverse on. But then I just had these 2 functions where I just checked the diagonals. And to check the diagonals, you pretty much, okay, I would find an A, right? Sorry, where's that? Pretty much when I ever find an A, I just check the diagonals, which is checking this diagonal and then this diagonal. There's only 2 diagonals, right? I just named them diagonal 1 or 2, right? And then I just built whatever string was from here. Pretend this is like -1 and +1. I took -1, 0, and +1. These are the indexes. And then I just basically checked, like, once I got those, I converted it into a string. So let's say we hit an A, right? And then we get S. And then we get an M here. When I collect it, I turn it into a string, SAM, right? And then afterwards I check if the, like, when I convert to a string it equals SAM. But then you have to check both cases. You have to like grab this element and that element, and if like this is a M instead, if this is a M instead, it should still pass because you're reading SAM this way. So that's why you have to do both mass and SAM checks for the diagonals. And then you have to do both of that for like this. You have to do it for this diagonal as well. And to do that, you could pretty much access it by like taking the current row and column you're at and like either adding 1 or minusing 1. So you could see, like, if I want to get the middle character, I don't add anything to the row and column. But if I want to get like what's row +1, column -1, that's this element, because I'm going down a row and I'm moving back a column. And then what's this one? Row -1 and column +1. That's this one because I'm going back a row and I'm moving a column. So now when I extract those, I just turn it into a string and then just check if it's SAM or MAS, right? And then yeah, every time I do an A, I just literally check the diagonals and return the result. So yeah, that's the solution. See y'all in the next video.